Okay, so what we are going to be looking at is the graphs of reciprocal functions. And if you know the graphs of sine, cosine, and tangent, we are going to actually develop the graphs of the reciprocal functions from those things. So for the graph of cosecant, I want you to dot in really lightly the graph of sine. Now, hopefully that's something you can do very easily. So I'll give you a minute to do that. And you know sine does this. I'm just dotting it in really quickly. That would come here, 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 and here. All right, so there's my sine graph. Now, what do we know about cosecant? You know that cosecant is 1 over sine of x. So let's think about that. That means when sine of x is equal to 0, cosecant would be 1 over 0, or in other words, undefined. So all these places, how does that translate graphically? All the places where sine is 0, I'm going to get vertical asymptotes. So the cosecant graph has asymptotes all throughout it. Perfect. Now these other values, again, 1 over sine means the reciprocal of. So this value that was 1, the sine of pi over 2 was 1. Well, what's the reciprocal of 1? Still 1. And let's do maybe this one that's at a half. Okay, these are at like pi over 6, the sine is 1/2. Those values would be 2. So I like to say it this way, and I know it's hard to do this on the screen or for you to see what I'm doing. I like to say crack it at the x-axis and you flip it out. In other words, this piece is going to flip out this way. This piece is going to flip this way. And this way. And this way. So what I've drawn in the red is the cosecant graph. Okay. So what was 1/2 becomes 2. So see, these are on 2s. But to get the general shape, again, these 1s stay exactly, and negative 1s stay exactly the same. And again, the graph of the red is the cosecant graph. I don't try to memorize it. I just think of sine because I know that one so well, and then I just develop the cosecant graph. So what's the period? Well, the period of cosecant, I have to have 1 up and 1 down parabola. I mean, I'll call them parabolas. And so that takes between 0 and 2 pi. So the period is 2 pi, just like sine is. Now, what is the domain? Well, we know from rational functions, domain is x can't be wherever the asymptotes are. So how am I going to write the asymptotes? Well, let's look at where they are. They're at 0, pi, 2 pi. Now, I know my graph stopped, but when you write domain, you have to write for the entire function. So that would be 3 pi, 4 pi, negative 2 pi. So I could say x can't be any multiple of pi. Perfect. And what's the range? Remember, it's the red. So I have to go low to high. So if I go low, this arrow is going down forever. So negative infinity up to -1 with a hard bracket. But if I ignore the blue, of course, it's the red, then I jump all the way right here to a y value of 1, and then I go to infinity. So there's the range. And sometimes, again, comma, sometimes you see it with that U in there. Either one is fine. I usually put a comma. And is cosecant an even or an odd function? Well, it's going to be the same as what sine is. And it is an odd function. And there you have it. That is cosecant. Now for secant, I want you to stop the video and literally, I want you to go through and do the exact same steps. But obviously, instead of dotting in sine, you're going to dot in cosine. So see if you can stop, see if you can get the graph and all the stuff. Now let's see if you got it. I'm going to dot in cosine. So cosine goes here, 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 and here. And boom, 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 and boom. Let's dot that in with my little valley. Perfect. And then what happens? Well, once again, secant is the reciprocal of cosine. So every time cosine is 0, I don't know if I said cosecant. Every time cosine is 0, secant is undefined. If I said that wrong, fix me. Okay, when cosine is 0, secant is undefined. So all those places where the cosine is hitting the x-axis, I have asymptotes. I do my crack and flip. My ones are going to stay the same. And so if I think about cracking and flipping, this one's going to go up like this. This one's going to go down like so. And this one is weird because you're like, oh, well, I can tell the difference because the secant graph has these two kind of that are, detached. Y'all, the only reason they're detached is, of course, because the graph, it said only graph it between negative 2 pi and 2 pi. Okay? So don't think that you're going to memorize it because, oh, those two are disjointed, because we could just draw one period of it. The key is knowing where the asymptotes are. Okay, secant is going to have asymptotes when cosine is 0. Think of the unit circle. Where is cosine 0? Here and here. So that's where I get the pi over 2 and the 3 pi over 2. What is the period of secant? Well, same thing. I've got to get one full up and one full down. So if I think about starting here and ending here, if I subtract those two things, that gives me 2 pi as well. What's the domain? X can't be, again, where the asymptotes are. Pi over 2, 3 pi over 2. Let's think about what the next one would be. 5 pi over 2. So can I say multiples of pi over 2? No, because a multiple of pi over 2 is 2 pi over 2, which I don't have an asymptote. So I have to put the word odd in there. Odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and of course the negatives as well. The range, well, gee golly whiz, it's the same range as cosecant, which you are exactly right. Just like sine and cosine are just a shift of each other, well, secant and cosecant are too. So they have the same range. Secant, is it even or odd? Well, what was cosine? Cosine was even. So is secant. Perfect. All right, graph of cotangent and tangent. Well, tangent you already know, but I'm wanting to kind of explain this in a certain way so that it can maybe help you memorize it a little bit. I'm not going to necessarily do cotangent from tangent, but I want you to think of it like this. Tangent, I hope you already know. Tangent, it kind of, I always remember that it kind of looks like x cubed when I look at the origin. So my asymptotes are here. Okay. And then my graph, of course, does this. Again, that one period there kind of looks like x cubed, and then it's just the repeat of that. So I'm just going to draw that several times. What I want to point out, though, that I think is helpful in the learning is this. As soon as I draw, if I start talking and still drawing, I'll probably make a mistake. So let me just finish that real fast. There we go. Here's the connection I need you to make. Okay, tangent. That is sine over cosine. Look at what's in the denominator. Cosine. So if cosine is in the denominator, the things that make it bad are going to be the same things that made what bad? Well, it's going to have the same domain as secant because secant is 1 over cosine. So do you see that the domain of tangent and secant are the same. That should make total sense. That should make total sense because the denominator of secant and tangent are the same thing. They both have cosine. And where is that bad? When cosine is 0. That's here and here. That's where I get that domain. What's the period of tangent? It's just pi. The range, pretty easy to see, all reals or negative infinity to infinity. And tangent is an odd function. So let me do cotangent this way. I'm not going to do it necessarily from tangent. I want to say this. Well, cotangent is going to have the same domain as whom? Well, cotangent is cosine over sine. So if sine is on the bottom, just like cosecant, cotangent is going to have asymptotes where sine is 0. So cotangent has asymptotes all at the pi's. And so his domain is going to be the same multiples of pi as what? Cosecant. Because again, cosecant is 1 over sine. They have the same denominators. So they have the same bad spots. Okay, could I also say it's where tangent is 0? Yes, you can look at those two graphs, but to me in memorization, it's easier for me to do cotangent with these thoughts. I don't necessarily do it from tangent. Okay, well, let's think of this. For cotangent, it's cosine over sine, so cotangent's going to be 0 when cosine is 0. That's all of these guys here. And then you think of one or two other points. At pi over 4, the cotangent is 1. At 3 pi over 4, which is right there, it's -1. So the cotangent is a decreasing function and just repeated over and over again. And you have this lovely graph. And there you go. I always remember tangent is increasing and cotangent is decreasing. The period of cotangents, well, I mean, you can kind of tell. It goes from 0 to pi and then it repeats itself. So the period is pi. The range is all reals. Or, of course, again, I said it on the last one, but just either one of those is fine. Cotangent is an odd function as well. So I hope you put that together and how you can memorize the domains, especially of all those reciprocal functions, is by thinking who's in the denominator. And that's going to be what you're going to be asked. So right now, you're responsible for knowing what the graph looks like and all of this information about that graph. All righty? All right. Peace out, peeps.